Guys, welcome back. This is going to be 6.5 day 2, and we're going to be talking about what we call the ambiguous case. Hopefully you guys don't hear the constant fan in the background. I'm sure that would be annoying if you did. Um, had to replace the water heater yesterday, and well, it got pretty wet, so running fans to make sure things dry up quicker. But anyways, we're going to talk about using law of signs still. And for the ambiguous case, we run into an issue where we don't know how many triangles there are. If you are given an angle, a side and a side, there's actually 3 potential cases you could have. Okay, and so we have to do extra work to figure out how many cases there are. So, the ambiguous case is when you have side-side angle. The way you remember that, it's the no word. Remember in geometry I caused issues? Same here. So when we throw everything together and you're given sides or angles, then you have to determine which way to use. Law of sines or law of cosines we'll talk about later. If you get side-side angle, it's the ambiguous case. You guys will learn to dread this one. So there could be 0, 1, or 2 solutions. So that's what we're going to be talking about today. So again, you pause the video and write this down if you did not already from yesterday. So basically, 3 cases, okay? Case number 1 is we're given an angle, the side opposite of that, and this side right here. Now the first case is that this side length is too short. It's just dangling here. You can't make a triangle, so there's no triangle. Now, you're going to see this a lot, B sine A. What that means is, if you think about sine of this angle, sine of A would have to equal, let's call this the height, okay? H over, the hypotenuse is B. Well, how do you solve for H? Times by B, those cancel. So really, this is the height of the triangle. B sine A equals the height. So what we have to do to determine how many cases there are is compare this side length over here to the height of our triangle. Okay? And so if it's smaller than the height, which obviously from the picture it is, then there's no triangle. There's no triangle that can be formed. Case number 2. Now this one gets interesting. So if A is smaller than the height, no triangle. If A is bigger than the height, then we have to do another test. You have to compare this side length A to this side length B. Okay. Now if A is greater than or equal to B, we only have one triangle, because the only one it could connect to is right here. If we made one over here, our triangle would look like that, and we wouldn't have the angle we were given, and so it'd be a whole nother triangle entirely. Okay, so the only one it could connect to would be this spot right here. So there's only one possible triangle if both these quantifiers are true. So you do have to run some tests beforehand. And case number 3, the worst. If A is greater than the height, we know there's not 0 triangles, so it's either 1 or 2. And then if A is less than B, there's 2 possible triangles, okay? So we have one possible triangle here and one possible triangle here. Now, there is something I want to point out, is that this side length right here, green and green, or red and red now, are the same side length. Okay? And that would mean that these 2 angles have to be the same. So what we're going to do, and what you're going to see in our next problem, is that these are this angle right here and this angle right here are going to be supplemental. So how we solve our 2 triangles is one has this angle measure, and one has this angle measure. Okay, but we'll get more into that when we have an example. Okay, so this is what some of the homework looks like. I'm a visual person. I like drawing the triangle. Now, when you draw this, I would recommend always putting the angle you're given in the left side, standard position. So I'm going to draw A, and that's 43.1. Now I always draw this dangling here. We don't really know if it'll reach or not, but A, the side length, equals 186.2, and then the side length, the other side length that you're given, I would not put here. I would always put in between this angle, or this angle and this side. So I would always draw your pictures like this. Okay, so now we need to find a potential height. So you remember it was B times sine of A equals the height. That was the formula we kind of figured out from the sine of A. Now it is important to note that sometimes these are labeled differently. So sometimes maybe they give you angle B instead of A. That would change this. So just know it's sine of this angle times this side length, okay? So we have 248.6 times sine of 43.1, and that's in degrees. So make sure we're in degree mode. So I'm going to do this right now. Sine of 43.1 times that by 248.6, and you get about 169.86. So the height is 169.86. So we have to compare A to the height. Okay, A to the height. Well, A is 186.2 and the height is 169.86. So based on what we talked about before, A is bigger than the height. So that eliminates having zero triangles for a solution. Okay, so we know there's at least one. There's either one or two solutions. So since A is bigger than H, now we have to compare A to B. Okay, well, A is 186.2. B is 248.6. Well, A is less than B. So if you recall, that means we're actually going to have two possible triangles. So we will have one here maybe, or we'll have one here. Okay, now the first one we solve is this guy right here. So I'm going to use the law of sines. So we know A, we know the angle A and the side length A. So over here, and let's find angle B, which would be this guy right here. That's usually how it's going to work. You're going to find this angle first. So if we're finding an angle, let's put the angles on top. So sine of 43.1 all over 186.2 equals sine of B all over 248.6. Now, got to solve for B. So let's multiply 248.6 over here. 248.6. And this right here is just a number. So you can have that in your calculator. And then to get B by itself, you'll do the inverse of sine. So sine inverse both sides. So I'll do the sine inverse of 248.6 times sine of 43.1 divided by 186.2, and you get B is about 65.82. Awesome. 65.82, and this is degrees. Okay, So 65.82. Sorry, I just have to write it down. Now we can find a third angle. Let's take 180 minus these two. 180 minus 43.1 minus 65.82. So this is about 71.08 degrees. Well, all we have to do to solve this triangle is to find C. So let's do law of sines again. So sine, except for finding side length this time, so I'm going to put the side lengths on top. So we got 186.2 over sine of A, which would be 43.1. It's getting pretty laggy. That's great. Equals C all over 70. Oh, sorry. Sine of 71.08 degrees. So again, this is just a number, so multiply this over here. So I'll do sine of 71.08 times by 186.2 divided by sine of 43.1, and that gets us 257.79. Okay. Now remember, this is one triangle. We have two cases. So for the first case, you solve kind of like how you did yesterday. And the second case is actually pretty easy. Now I'm going to have to erase everything on this slide, so feel free to pause the video and write everything down. And the way I would do this, I would maybe label one triangle 1, because you're going to have a new set of data here. And so maybe on your own you'd have triangle 1, triangle 2, copy the AAB down again. Okay. Now, I'm going to redraw our triangle. A, B. Now remember, A was bigger than the height, but it wasn't bigger than B. So there's two potential cases where it can hit. It could hit here, or it could hit here, somewhere around there. If it hit here, the angle we found earlier was 65.82 degrees. And so this angle right here would also be 65.82. But for our actual triangle, let me switch colors. Our actual triangle that we're solving, the new angle for angle B would be the supplemental angle. So the only thing we have to do for case 2 is find a supplemental angle and put that in for this angle B. So you just do 180 minus 65.82 degrees, and you get 114.18. Okay, so there's actually one less step in this case too, because before we had to do the law of sines to figure this out. Here, no. So now, all we have to do is find our C. So we can find our angle C, 180 minus 43.1 minus 114.18, and we get about 22.72 degrees. Well, now we just have to find C. So I'm going to do our given. I usually like to use our given. And we want to find side length, so I'm going to put that on top. So C over sine of 22.72 equals 186.2 all over sine of 43.1. Got to solve for C. So multiply sine of 22.72 to both sides. Okay, sine 22.72. And now let's do the math there. 186.2 divided by sine of 43.1 times by sine of 22.72, and C equals 105.25. 105.25. So on your homework, the way your work would show, on my previous slide, that would be like your first triangle, and this would be your second triangle. So to solve for this triangle, you actually need to find two triangles. I'm sorry. This is the one that we don't like. We're okay with the one case or two case. Alright, so fresh problem. Now again, I'm going to draw my picture. I'm always going to put the angle given over here. So we got 41 degree angle right here. We know the side opposite of that is 40. B is 89. So we have to find the height. The first thing you have to do is find the height. So the height from the B times sine A would be 89 times sine of 41. So 89 times sine of 41. And that gets you 58.39. So this height right here is 58.39. Now, this is smaller, so we got to compare A to H. A is smaller than H, right? Which means if we try to make a triangle, this guy would just be dangling here. We could not make a triangle. So there's actually no triangle, or you could say no solution. See, that's the fun one. If you get that this side length is smaller than the height, we don't have a triangle. So that makes it a little quicker. Well, by process of elimination, if I talked about 2 cases and 0 cases, this will probably turn out to be the type of problem with 1 case. Let's find out though. So we have triangle with angle A over here. It's an 80-degree angle. This is 100. This is 10. You gotta find the height. So the height would equal, sorry, brain fart, 10 times sine of 80 degrees. So I'm going to do that in my calculator. 10 times sine of 80, that's about 9.85. So the height compared to A is bigger, right? A is 100. The height is 9.85. So that means we have 1 or 2 triangles. Now the second condition we have to check if we have that A is bigger than the height is A to B. Now B is 10, A is 100, so A is way bigger. So remember, if A is bigger, there's only 1 case because we couldn't swing over here, otherwise it would hit over here and that would mess up with our angle. So the only case is going to be over here. So we actually only have 1 case where this will work. So now we just solve like normal, just like you would yesterday. So we're finding angle, so I'm going to put sine of 80 on top over 100 equals sine of B over 10 times by 10 over here. So this right here is just a number you can plug in your calculator, 10 times this divided by this. And then we got to get B by itself. So you're going to take the inverse sine of both sides. So B would equal, let's do sine inverse of 10 divided by 100. 10 times sine 80 divided by 100. And you get B is about 5.65, which makes sense because this side length is much smaller than this side length here, so it makes sense that this angle measures much smaller. And now we can just find angle C. So 180 minus 80 minus 5.65, so you get 94.35 degrees. That would be angle C, which would be up here. Now we just got to find the side length C. So let's just do law of sines. So again, I'm going to start with the given. Just because of given, we didn't have to round it all. I don't think I rounded this. Maybe I did. I don't remember already. But no rounding, so it throws off, it minimizes errors. So we're looking for a side length, so I'm going to put this side length on top. So 100 over sine of 80 equals side length C over sine of 94.35. So we just got to solve for C, so times by sine of 94.35. Find out what that number is. So I'm going to do sine of 94.35 times 100 divided by sine of 80, and you get about 101.25. Okay, and so that's the lesson today. Hopefully that was okay. I think the only really challenging one is the 2K scenario, but then really the only thing you have to do extra is in that second triangle find a supplemental angle and just solve for these two right here, okay? And so this will be your homework for today. Now keep in mind that they could throw the givens around. So what if they gave you angle C and side length C and B? So you don't necessarily have to use A to B, right, or A to H, because in this case this would be A and this would be little a. So it's based on what you're given. So to start off, you want to compare this side length to the height, and then this side length to this side length, okay? So they could switch things around. So don't always use A sine B or whatever, or B times sine A, because sometimes you might not be given angle B or angle A and side length B, okay? So give this a try. And then Monday, I think we'll throw what we learned yesterday and today together. Okay, so with that, have a good weekend, Jays.